Have you at any point looked toward the night sky and considered the confounding dance of the stars? One of the magnificent performers, Betelgeuse, a red supergiant star roost on the shoulder of Orion, has recently caught everyone's attention in the cosmic community. In 2019, this brilliant giant staggered specialists with a surprising darkening, alluding to an inevitable grand event. Join me on an excursion as we dive into the confusing universe of Betelgeuse, exploring its remarkable qualities, unraveling the science behind its impending supernova, and uncovering the new revelations brought to us by the wonder of evolution, the James Webb Space Telescope. In the vast expanse of the universe, where stars shine like gems in the night sky, one particular heavenly entity has captivated astronomers and stargazers alike, Betelgeuse. This red supergiant holds the promise of a spectacular cosmic event, the Betelgeuse supernova. What was once a mere shimmer in the cosmic tapestry transformed into a source of bewilderment when, in 2019, Betelgeuse began to fade, prompting scientists to question the fate of this celestial giant. Betelgeuse stands out as the second brightest star in the Orion constellation. Its distinct reddish hue and variable behavior make it an intriguing subject for astronomers. Despite being the 10th brightest star in the night sky, Betelgeuse's unique name, meaning the armpit of the giant, adds an aura of mystery to its celestial persona. Situated at an estimated distance of 430 to 724 light-years from Earth, Betelgeuse is not just brilliant but also one of the closest red supergiants to our planet. With a surface temperature of 3,600 Kelvin, it dwarfs our Sun, emitting more than 100,000 times the light and boasting a size over 1,000 times greater. A glimpse over the eastern horizon reveals Betelgeuse, the stunning red supergiant in the Orion constellation, briefly vanishing behind an asteroid, an event that transcends the ordinary. This marks a celestial gathering, a dance of shadows and light. On Monday, December 11th, this rare cosmic alignment will take place. Betelgeuse, a beacon in the vastness of space, will be occulted by an asteroid named 319 Leona. For a brief moment, Betelgeuse's brilliant glow will be dimmed, creating a celestial ring of fire. However, this spectacle will not be visible to everyone. Only those situated along a narrow path stretching from Asia to Florida and Mexico through southern Europe will witness this cosmic ballet. As we contemplate the rarity of such events, a question arises. How often does the universe orchestrate these ethereal performances, and what secrets might they reveal? Could this celestial tango provide a glimpse into the intricate workings of the universe, or is it merely a fleeting interruption in the grand cosmic symphony? As Betelgeuse briefly disappears behind Leona, stargazers armed with telescopes and cameras eagerly anticipate a 15-second spectacle. This fascinating event promises to unveil more about both Betelgeuse and its unlikely companion, Leona, a slowly rotating asteroid nestled within the main asteroid belt between Mars and Jupiter. The anticipation is real, as scientists remain uncertain whether Leona will completely eclipse Betelgeuse, plunging it into total darkness, or whether a fiery edge will frame the star in a mesmerizing ring of fire. Astronomer Gianluca Massi, founder of the Virtual Telescope project, adds to the intrigue, stating that the exact outcome remains unknown, making the event even more captivating. This serves as a reminder that, in the vastness of the universe, uncertainty reigns, and every cosmic event is a unique chapter in an ever-evolving astronomical saga. The great eruption of Betelgeuse, a cosmic mystery unfolds. As we await the celestial eclipse, let us rewind to a moment of cosmic upheaval, the great dimming of Betelgeuse, a celestial phenomenon that left scientists in awe. Betelgeuse ejected a staggering amount of mass, 400 billion times more massive than a routine solar coronal mass ejection, CME. Our Sun, a familiar astronomical neighbor, frequently sheds its outer layers in CMEs. However, Betelgeuse's ejection was an unprecedented cosmic anomaly, a titanic burst that stunned astronomers. The expelled mass, likely weighing several times more than our Moon, was hurled into space in a breathtaking display of stellar excess. The root cause of this extraordinary astronomical light show remains elusive. Scientists speculate that a plume of gas surging from within the star, aided by Betelgeuse's 400-day pulsation cycle, may be responsible. Yet, the astronomical detective work is far from complete, and the precise mechanism behind this grand event remains shrouded in mystery. As Betelgeuse recovers from its great dimming, some researchers shift their focus to the star, utilizing powerful instruments like the Hubble Space Telescope. This technological marvel, capable of peering into the ultraviolet realms, provides a closer view of Betelgeuse's atmospheric layers. The Great Dimming, a cosmic event observed by humanity due to our proximity to Betelgeuse, serves as a reminder of the countless mysteries lurking in the universe. Into the cosmic unknown, the fate of Betelgeuse. As the cosmic dust settles around Betelgeuse, questions about its future linger. While it is certain that Betelgeuse will eventually go supernova, the exact timeline remains uncertain. Scientists predict that this cataclysmic explosion, marking Betelgeuse's transformation into either a neutron star or a black hole, is still an event approximately 100,000 years away. In the cosmic theater, Betelgeuse is both a performer and a puzzle. Its supernova destiny, set to illuminate the cosmic canvas with brilliance, invites us to ponder the mysteries of the universe. The celestial clock ticks on, and as we observe Betelgeuse from our backyard observatories, we become witnesses to the grand ballet of creation and destruction. Hubble's meticulous eye continues to scrutinize Betelgeuse, its ultraviolet gaze unraveling the layers of the star's atmosphere. The star's peculiar behavior, marked by dramatic dimming and subsequent recovery, highlights the dynamic and ever-changing nature of the universe. In this ongoing cosmic saga, humanity's exploration of Betelgeuse remains humble. With each observation, new questions arise, fueling our insatiable curiosity. The dance of the universe. In the vast Milky Way, where stars reign, Betelgeuse stands out among the estimated 200 red supergiant stars. Its colossal size and influence extend far beyond our solar system. If Betelgeuse were to replace our Sun, its reach would extend past Jupiter, engulfing Mercury, Venus, Earth, and Mars. Like all stars, Betelgeuse follows a life cycle defined by the fusion of hydrogen atoms in its core. As it nears the end of this cosmic journey, it sheds mass unevenly, paving the way for its inevitable fate. For now, we continue to gaze at Betelgeuse, a celestial wonder whose story is still unfolding, one that reminds us of the grandeur and transience of the universe. A nebula now envelopes the star, a stellar masterpiece spanning 30 astronomical units and vastly larger than Betelgeuse itself. The march toward catastrophe is truly underway. A red star of Betelgeuse's magnitude loses approximately 1 solar mass at regular intervals, clearing the path for its eventual demise. As the star depletes its primary fuel, hydrogen, and transitions to helium and carbon burning, a cascade of reactions unfolds. Neon fuses with carbon, producing iron, and the resulting energy release triggers a supernova, a dazzling showcase of nature's power, capable of outshining 10 billion suns. The mystery of the dimming star takes another twist, as Betelgeuse's story reveals an unpredictable aspect, its irregular fading. In 2019, astronomers and skywatchers observed a fading pulse, a phenomenon that persisted for months, defying conventional expectations. Was Betelgeuse dying, or was this a prelude to its impending supernova? The mystery deepens, Betelgeuse's unpredictable behavior. As scientists turned their most powerful instruments toward Betelgeuse, they were met with more questions than answers. The 2019 dimming event was unlike anything observed before. Was this just an unusual stellar hiccup, or was Betelgeuse signaling the final stages of its life cycle? For decades, astronomers have studied the star's periodic pulsations, expansions and contractions driven by internal processes. However, the Great Dimming suggested something more dramatic. Observations from the Hubble Space Telescope and other advanced instruments revealed that Betelgeuse had expelled an enormous cloud of material, which likely cooled and condensed into dust, temporarily blocking the star's light. This revelation provided some clarity, but it also raised new concerns. Was this massive ejection a sign that Betelgeuse was on the brink of collapse? Or was it just another phase in its unpredictable life? Scientists remain divided, but one thing is certain: Betelgeuse continues to defy expectations. The countdown to a supernova. While the exact timeline of Betelgeuse's supernova remains unknown, astronomers are confident that the explosion will occur within the next 100,000 years. When it does, it will be one of the most spectacular astronomical events in human history. A Betelgeuse supernova would be visible even during the daytime, shining as brightly as the full moon for weeks before gradually fading. It would be an unprecedented opportunity for modern science to study a supernova in real time, providing insights into stellar death, neutron star formation, and potentially even black hole creation. Despite the excitement, there's no cause for alarm. Because Betelgeuse is relatively close to Earth, some have wondered if its explosion could pose a threat. However, scientists assure us that the star is too far away. Its supernova will not endanger life on our planet. Instead, it will be a celestial spectacle, enriching the cosmos with newly formed elements that may one day become part of future stars and planets. The legacy of Betelgeuse. Even in its current pre-supernova state, Betelgeuse is already shaping our understanding of stellar evolution. Its unexpected dimming has led scientists to re-evaluate models of how red supergiants behave in their final centuries. New discoveries, such as the massive dust ejection, highlight the complex interactions between a dying star's outer layers and its surrounding space. The James Webb Space Telescope, JWST, with its unprecedented infrared capabilities, is poised to provide even deeper insights. By analyzing the star's infrared emissions, JWST can peer through dust clouds to reveal what's happening beneath the surface, helping astronomers refine their predictions about when Betelgeuse might finally explode. A cosmic dance that continues. As we continue to observe Betelgeuse, we are reminded of the vast, ever-changing nature of the universe. Each new discovery deepens our appreciation for the complexity of stellar life cycles, from birth to brilliant demise. One day, perhaps thousands of years from now, future civilizations will witness the moment Betelgeuse transforms from a red supergiant into a brilliant supernova. Until then, we watch and wait, captivated by the mysteries of this celestial giant and the cosmic dance of the stars. Telescopes turned toward Betelgeuse. They were met with proof of an uncommon dimming. Despite the fact that the star's brightness eventually returned to normal, the star, over 5 billion years old, had entered the latter stages of its existence, signaling the potential for a supernova event. However, the exact timing remained elusive, shrouded in the mystery of Betelgeuse's unique behavior. Unraveling the mystery. Wide examinations of Betelgeuse date back to the 1st century BCE, yet the cause of its sudden and unusual dimming remains a puzzle. Astronomers speculate that the star's outer shell expands and contracts in cycles, causing fluctuations in its diameter and surface temperature. The star's pulsating nature, combined with limb darkening, contributes to variations in visual emissions, further complicating efforts to decode Betelgeuse's secrets. Betelgeuse's journey through the universe takes an exceptional turn. It was identified traveling through the interstellar medium at an astonishing speed of 30 kilometers per second, having been ejected from its birthplace in the Orion OB1 Association, the stellar nursery of Orion's belt. This ejection left behind a bow shock spanning more than 4 light-years. However, measuring distances to red supergiant stars, especially unpredictable ones like Betelgeuse, poses significant challenges in astrophysical calculations. The star's actual diameter remains a moving target due to its pulsating nature and limb darkening, which alter the color and intensity of its visual emissions. The James Webb Space Telescope's discovery. The James Webb Space Telescope, JWST, a groundbreaking instrument poised to revolutionize our understanding of the universe, turned its gaze toward Betelgeuse. The data it collected stunned the astronomical community. With its advanced capabilities, high-resolution imaging, spectroscopy, and multi-wavelength observations, JWST provided unprecedented insights into the star's composition, dynamics, and mysterious dimming events. As scientists analyzed JWST data, a new narrative emerged. The telescope's findings illuminated the complexities of Betelgeuse's outer layers, revealing subtle changes that hinted at the star's impending transformation. This discovery sparked excitement and speculation, challenging existing theories and inspiring a renewed wave of inquiry. Could Betelgeuse go supernova? The possibility of Betelgeuse undergoing a supernova raises a fundamental question. What impact, if any, would this cosmic event have on Earth? While the immense distance to Betelgeuse provides a degree of cosmic safety, the sheer power of a supernova cannot be ignored. Discussions continue about the potential consequences, from visible astronomical phenomena on Earth to possible effects on our planet's atmosphere. The enigma of Betelgeuse's supernova timing. The mystery of Betelgeuse's supernova remains an elusive question. Some astronomers argue that the 2019 dimming episodes could indicate the star's imminent demise, while others propose alternative explanations. The debate surrounding Betelgeuse's timeline invites us to consider the vastness of the universe and the unpredictability of stellar phenomena. Unraveling Betelgeuse's photospheric puzzle is no simple task. As we delve into its complexities, we encounter the intricate interplay of its photosphere and circumstellar envelope. The photosphere, the term used to describe a star's visible surface, becomes a stage for material ejected from Betelgeuse, creating a mesmerizing display of light emission and absorption. A glimpse into Betelgeuse's evolution. In July 2009, the European Southern Observatory, ESO, provided a rare glimpse into Betelgeuse's cosmic performance. Images captured by the Very Large Telescope Interferometer, VLTI, revealed a massive gas plume extending 30 astronomical units from the star, showcasing a scene of multiple mass ejections from Betelgeuse's atmosphere. Astronomers discovered at least 6 circumstellar shells surrounding Betelgeuse, raising questions about the puzzling mass loss in the late stages of a star's life. The evolution of Betelgeuse's dynamics continues to fascinate scientists. The mechanisms driving mass loss in red supergiants remain shrouded in mystery, but these colossal stars play a crucial role in the cosmic recycling of matter that shapes galaxies. Recent advancements in interferometric techniques offer hope as astronomers strive to unlock the secrets hidden within Betelgeuse's atmospheric dance. A massive eruption and the 2019 dimming mystery. In 2019, the Hubble Space Telescope and other observatories detected a significant event, an enormous surface mass ejection from Betelgeuse. Unlike typical coronal mass ejections, CMEs, from the Sun, this event expelled an astonishing 400 billion times more mass. The consequences were immediate. Betelgeuse experienced a sharp decline in brightness from October 2019 to mid-February 2020. However, the dimming event took an unexpected turn, leaving astronomers perplexed. As Betelgeuse's brightness stabilized, theories emerged. Some scientists attributed the dimming to massive circumstellar dust grains, while others pointed to gigantic star spots. In 2022, a study ruled out dust absorption, instead crediting the dimming to huge star spots. However, a twist arose in August 2020, when a second dust cloud was detected. This dust, traced back to a cooling region on Betelgeuse's photosphere, was speculated by Hubble to have resulted from a surface mass ejection. During this cooling phase, material expelled from the star condensed into a dust cloud, temporarily blocking Earth's view of Betelgeuse. The future of Betelgeuse. The dramatic dimming of Betelgeuse raised fundamental questions about stellar behavior. Astronomers now propose an additional hypothesis. Beyond the visible effects, Betelgeuse's photosphere undergoes a process of rejuvenation, displaying increased luminosity over time. This unusual behavior arises from the star's internal structure, which oscillates like a disturbed bell, affected by its natural cycles. These discoveries provide valuable insights into the aging processes of red supergiants like Betelgeuse, shedding light on the delicate balance between mass loss and the impending supernova explosion. However, the lack of compelling evidence linking mass ejection to an imminent supernova adds another layer of intrigue to Betelgeuse's story. Astronomers continue to monitor Betelgeuse closely. Their observations fuel new debates and theories about its fate and eventual transformation into a supernova. As the cosmic clock ticks, we eagerly anticipate the next chapter in the unfolding drama of Betelgeuse's enigmatic life and its inevitable end. The implications of Betelgeuse's supernova. When Betelgeuse eventually goes supernova, it will be one of the most spectacular celestial events witnessed by humanity. The explosion will release an immense amount of energy, momentarily outshining the entire Milky Way galaxy in visible light. But what would this mean for Earth and the surrounding cosmic environment? Will Betelgeuse's supernova affect Earth? Betelgeuse is located about 640 light-years from Earth, which is a safe distance for our planet. While the radiation from the explosion will be intense, it is not expected to pose a direct threat to life on Earth. However, astronomers predict several key effects. 1. A second sun in the sky. When Betelgeuse explodes, it will likely shine as bright as the full moon, possibly even visible during daylight hours. This brightness could persist for weeks or months before gradually fading. 2. A new nebula in Orion. After the explosion, Betelgeuse's remnants will expand into a beautiful supernova remnant, forming a glowing nebula that may be visible from Earth for thousands of years. 3. Cosmic ray emissions. Supernovae produce cosmic rays, high-energy particles that travel through space at nearly the speed of light. While Earth's magnetosphere and atmosphere provide effective protection, sensitive satellites and space missions could detect an increase in cosmic radiation. 4. Scientific revelations. This supernova would provide an unprecedented opportunity for astronomers to study stellar evolution in real time. Advanced telescopes like JWST, the European Extremely Large Telescope, EELT, and future space observatories would closely analyze the event, improving our understanding of how stars die and how their material is recycled into new stars and planets. Betelgeuse's role in cosmic evolution. seeding the cosmos with new elements. Supernovae play a fundamental role in the chemical enrichment of the universe. When Betelgeuse explodes, it will scatter elements like carbon, oxygen, iron, and heavier metals into space. These elements are the building blocks of new stars, planets, and even life itself. The Orion Nebula's future. Betelgeuse's explosion will likely reshape its surrounding environment, potentially impacting the Orion Molecular Cloud Complex, one of the most active star-forming regions in the Milky Way. The shock waves from the supernova could trigger the formation of new stars, continuing the endless cycle of stellar birth and death. The countdown to Betelgeuse's explosion. Astronomers are still uncertain when Betelgeuse will go supernova. The star could explode tomorrow, in 100 years, or in 100,000 years. However, recent observations suggest it is undergoing significant changes, possibly signaling that its final moments are approaching. 1. Unprecedented dimming and brightening. The 2019 dimming event was one of the most extreme brightness variations ever recorded in a red supergiant. Although the star returned to normal, its behavior remains erratic. 2. Internal structural changes. Data from JWST and Hubble indicate shifts in Betelgeuse's internal convection currents, suggesting that deep instabilities may be developing. 3. Helium burning phase. Some models suggest Betelgeuse has entered its helium burning phase, the final stage before a core collapse supernova. How will we know when Betelgeuse is about to explode? Before a supernova occurs, astronomers expect to see several warning signs. 1. Intense neutrino emissions. As Betelgeuse's core collapses, it will release a massive burst of neutrinos, nearly massless particles that can escape the star's interior before light does. Neutrino detectors like Super Kamiokande in Japan would likely detect this burst hours or days before the explosion becomes visible. 2. Sudden X-ray and gamma-ray bursts. Space telescopes, such as NASA's Swift Observatory, would likely detect an increase in X-ray and gamma-ray emissions in the final moments before collapse. 3. Unstable light curves. Continuous brightness fluctuations could indicate a rapid increase in energy release, a hallmark of an impending supernova. The legacy of Betelgeuse. Whether Betelgeuse explodes within our lifetime or much later, its scientific and cultural impact is already enormous. A celestial icon, as one of the most recognizable stars in the night sky, Betelgeuse has been observed for centuries, inspiring myths, literature, and scientific exploration. A stellar laboratory, Betelgeuse provides a real-world case study for understanding the life cycles of massive stars. A future supernova remnant. Long after its explosion, Betelgeuse will leave behind either a neutron star or a black hole, forever altering the structure of the Orion constellation. As we watch and wait, Betelgeuse reminds us of the vastness and dynamism of the universe. One day, when it finally erupts in a breathtaking supernova, it will mark the end of one chapter and the beginning of countless new ones in the cosmic story of creation.